So in class today we talked about greatest common factor, and we brought information forward from 5th grade about what greatest common factor was. You have to think of your words. Greatest is most, common is what they share or what's the same, factor is the numbers that you multiply together. So let's look at the first one. Miguel collects insects. He has 18 grasshoppers, 9 crickets, 21 ladybugs. Okay, those things are important to us answering the questions. For a science project, he will display an equal number of each kind of insect in a jar. What is the greatest number of jars Miguel can make if he uses all of the insects? So with greatest common factor, one of our key words to remember, and I'm going to put this over here, is the words greatest number, because that's going to remind us that we're looking for the greatest common factor. So how do we go about getting it? First, we need to find all the factors for the first number, which is 18. If you're not comfortable going straight to a T-chart, you can always do a tree and then put them into your T-chart. If you can go from straight to a T-chart, it'll save you some time. So 1 times 18, 2 times 9, 3 times 6. And that's it for the 18. Then we're going to find all factors for the number 9. 1 and 9, 3 and 3 is all we've got, because then it just repeats. And then last one is 21. 1 and 21, 3 and 7, and that's it. So then we need to look at all three numbers and look at, okay, which numbers do they have in common, or what do they share? Do they all have a 1? Yes. Do they all have a 2? No. Do they all have a 3? Yes. Do they all have a 6? No. Do they all have a 9? That one does, but that one does not, so no. 18? No. So they only have in common 1 and 3. Well, which one is greatest? The 3. So we go back into our question, and it says, what is the greatest number of jars? So the greatest number of jars is 3 jars. And I'm going to box my answer so that my teacher knows exactly what my answer is. Okay, so number 2. 20 yellow buttons, 12 orange buttons. We're making bracelets, necklaces. She divided all of her buttons into groups, giving each necklace the same number. What is the greatest number? There's that key word again, greatest number, and we're trying to do necklaces. So again, we're going to find all factors of 20. We've got 1 times 20, 2 times 10, 3, there's no 3, 4, yes, 4 times 5, and then it would start over, so we're going to stop there. And then we need 12. 12 would be 1 and 12, 2 and 6, 3 and 4, and we're going to stop there because it would start repeating. So which numbers do they have in common? They both have a 1, they both have a 2, they both have a 4, 5 no, 10 no, 20 no. So they share 1, 2, and 4. Which one is the greatest? 4. Then we look back up in our question and make sure we're answering the question. What is the greatest number of necklaces they can make? She can make 4 necklaces. Let's have you try number 3 on your own. Pause the video, try it, and then come back and check. Okay, so you should have tried number 3 on your own. It says that she has 24 rulers, 16 packages of markers, 18 poster boards. Oh, it's a he, not a she, sorry. He wants to divide all the supplies equally among all the work tables. What's the greatest number of tables he can prepare? So there's that key word again, greatest number. So we have 24 rulers, so we need to find all the factors for 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6, then it would repeat, so I'm going to stop. 16, all factors for 16. 1 and 16, 2 and 8, 3, no, but 4, yes, and it repeats, so we're done. Then number, let's see, 18. 1 times 18, 2 times 9, 3 times 6, 4, no, 5, no, and it would repeat, so we're done. What do they have in common? 1, 1, 1. 2s, yes. 3s, not all. 4, not all. 6, no. 8, no. 12, no. 24, no. That means with the supplies, if he wants each table to have the same number of supplies, then he can only prepare 2 tables, because 2 is our greatest common